feet is a hidden body of water, trapped by at least one confining layer of clay or rock. Actually, it's likely there are multiple layers of water and clay or rock below the surface. It's called a confined aquifer, the first basic concept of groundwater we're covering in this series of videos. A confined aquifer is a geologic formation, sediment, or rock that contains a body of water trapped within sediment underneath the ground by at least one confining layer. A confining layer is a layer of clay or rock that water has a very hard time passing through. For example, this could be a layer of clay or shale. Because of this confining layer, water in a confined aquifer is usually under pressure since it is caught between two confining layers. So when breached by a well, for example, water will flow upward, sometimes even to the surface. For this reason, confined aquifers are often called artesian aquifers. There are two types of confining layers. One called an aquitard, which generally refers to a layer that slows but does not completely stop water from passing through. The other is called an aquiclude, which is a layer that is impermeable or does not allow any significant amount of water to pass through. So how does water get into a confined aquifer if it has a hard time passing through a confining layer? In these aquifers, some water does come through the confining layer. However, this process can take hundreds of years. Most water finds its way into the aquifer through an unconfined area, usually much further upslope from where we'd like to put our well, and travels for hundreds or thousands of years through the sediment to where our well is. To learn more about groundwater, keep watching our series on groundwater basics. Thanks for watching.
You may have relaxed in a natural hot springs pool, or seen the old faithful geyser blasting hot water into the air in Yellowstone National Park. But have you ever thought of where all that heat comes from? Well, it comes from deep beneath the surface of the Earth, and it's called geothermal energy. And we can use it to generate clean, renewable electricity. Okay, here's how geothermal works. Heat from the Earth's crust warms water that is seeped into underground reservoirs. In some places, when water becomes hot enough, it can break through the Earth's surface as steam or hot water. This usually happens where the Earth's crust, or plates, meet and shift. In the past, taking advantage of geothermal energy was limited to areas where hot water flowed near the surface. But as geothermal technologies advance, we can leverage even more of these natural, renewable energy sources. Engineers have developed a few different ways to produce power from geothermal wells drilled into the ground. Have a look at this. It's a dry steam geothermal power plant, and it's the most common type of geothermal technology used today. Underground steam flows directly to a turbine to drive a generator that produces electricity. Pretty straightforward. Another geothermal technology is called a flash steam power plant. A pump pushes hot fluid into a tank at the surface, where it cools. As it cools, the fluid flashes, or quickly turns into vapor. The vapor then drives a turbine and powers a generator. A binary cycle plant works differently. It uses two types of fluid. Hot fluid from underground heats a second fluid, called a heat transfer fluid, in a giant heat exchanger. The second fluid has a much lower boiling point than the first fluid, and so it flashes into vapor at a lower temperature. When the second fluid flashes, it spins a turbine that drives a generator. The environmental benefits of this clean, round-the-clock, renewable energy source are substantial. Low emissions, small physical footprint, and minimal environmental impact. The few byproducts that can come up are often re-injected underground. Geothermal energy can also help recycle wastewater. In California, wastewater from the city of Santa Rosa is injected into the ground to generate more geothermal energy. Some plants do produce solid waste, but that solid waste may contain minerals that we can remove and sell. which lowers the cost of this energy source. The U.S. Geological Survey estimates that untapped geothermal resources in the United States, if developed, could supply the equivalent of 10% of today's energy needs and cut our dependence on fossil fuels. In fact,